Okay. There's a question of CAT 2022, slot 3. What's given here? A triangle ABC. This is triangle ABC. AB is 8 and AC is also 8. It's an isosceles triangle. A circle drawn with BC as a diameter is talking about this smaller circle. Passes through A. It will pass through A. BC is a diameter. So midpoint of that diameter will be the center for the smaller circle. That is OB and OC will be the radius. Another circle drawn with center A passes through B and C. The bigger circle, the center is A and it passes through B and C. So the radius of the bigger circle, let's take it equal to R, must be equal to 8. Let's the radius of the smaller circle is smaller, which must be equal to OB or OC. Yes, then the area of the overlapping region between the two circles. Let's try to find out the value of small r here. This angle has to be 90. Reason is this is a diameter, an angle in a semicircle. I'm talking about the small circle, smaller circle. This angle has to be 90 because angle in a semicircle is 90. So can we say AB square, which is 8 square, plus AC square, this is also 8 square, must be equal to BC square. This will give you 64 and 64, that is 128. 128 is equal to BC square. So what is the value of BC? It's root of 128 or the radius, that is half of BC, OB or OC. This is equal to small r, must be equal to root of 128 divided by 2. This is OB or OC. Now, what are you looking for? In the area of the overlapping region between the two circles. I'm talking about this part, BAC, this complete area. Let's try to divide this area into two parts. The first one would be this one. This is the overlapping area. Can I say this is equal to area of the small, half the area of the smaller circle? Because exactly this is diameter, so it will divide the circle into two equal parts. So area of this region, which I've shaded with green color, must be equal to what? Area of the smaller, half the area of the smaller circle. That is half of pi of r square. This is the overlapping region. There's something more. What's that part? This one. How do we calculate this one? Can I say there's a minor segment of the bigger circle? And how do we calculate the minor segment of the bigger circle? I can say that area of the sector, this sector, minus area of this triangle. So I need to add what? Overlapping region. Area of the sector minus area of the triangle ABC. Sum of these two will give me the overlapping region between the two circles. Now, what was the value of r? It was root of 128 by 2. So how do we write it? 1 by 2 pi root of 128 by 2 square will be 128 by 4. This is equal to area of half the area of smaller circle plus how do we write the area of sector? That is theta. The angle is already known to me. That is 90. 90 by 360 into this was a sector of bigger circle. So I should write pi capital R square. What was capital R? It was 8. So 8 square minus area of triangle ABC. This triangle ABC is an isosceles right angle triangle. So area will become half of base, which is 8, and height is also 8. So what do we get from here? This will cancel it out. How many times? 32 times. And 32 by 2 is 16. So I'll get 16 pi here plus 90 by 360 will be 1 by 4. 64 by 4, that is 16 pi minus 8 into 8 is 64. 64 by 2 is what? 32. So effectively, I get how much? 32 pi minus 32 bit. If you take 32 common, the answer has to be what? 32 into pi minus 1. This has to be what? The area of the overlapping region between the two circles.